Okay, let's continue this discussion on the traditional science and the design science and learn a bit more about the perspective of this author. The two scientific processes. Traditional science is about pursuit of knowledge. It's about explaining and understanding phenomenon. We already saw that. Looking at the disparate work in many scientific disciplines, it's clear that there are countless ways in which that can be done. However, when focusing such investigation on the overall strategies applied for the various scientific endeavors, sometimes referred to as the logic of inquiry, the diversity of methodologies and methods can be condensed into four overall paradigms. In other words, the search for explanation and understanding can be inductive, deductive, retroproductive. Sorry, let me start that again. Inductive, deductive, retroductive, or abductive. Right? So new terminologies we all learn. The inductive research strategy aims to establish universal generalizations to be used as pattern explanations by accumulating observations and constructing generalizations and using these as patterns to explain further observations. We have all done induction in logic and so on. Observation comes before conceptualization and further observations. The deductive research strategy, on the other hand, aims to test theories to eliminate false ones and corroborate the survivor by constructing a theory and expressing it as an argument, deducing hypotheses and testing these against observations. Alright, so induction is where you have something and you expect that the third thing, if A equals B and B equals C, then A equals C kind of approach. Whereas we said in science, we take data, hypothesize, get more data to test the hypothesis and then theorize. Conceptualization comes before observation and further conceptualization. Here, the reproductive strategy, retroductive strategy is so tempting to look at a word and say something you already know, right? This is a cognitive bias. So the retroductive research strategy has similarities and differences with both inductive and deductive strategies. It aims to discover underlying mechanisms to explain observed regularities. Why are some things repeating themselves? By observing a regularity, constructing a hypothetical model of the mechanisms capable of producing the regularity, and test the model against observations. Initial observation comes before conceptualization and further observation. Finally, the abductive research strategy is mainly used in the social sciences, as it entails an ontological assumption that views social reality as the social construction of social actors. It aims to understand social life in terms of social actors' motives and accounts by discovering everyday concepts, meanings, and motives, and translate these accounts to scientific accounts and developing theory to test iteratively observation. So then observations here come before conceptualization and further observation, which sounds like hypothesis building and theory building. Let's redefine ontological, because I'm not a social scientist. I keep on not being able to state it properly. So this is the ontological is relating to the branch of metaphysics dealing with the nature of the being. So ontological arguments showing the relations between the concepts and categories in a subject area or domain and the ontological database. So ontological assumption here is that social reality as the social construct of social actors. So that's the metaphysics of the nature, the branch of metaphysics dealing with the nature of being. I have to keep reading it because I don't have an intuitive sense. Since I am myself new to this, I'm learning and providing the course as I go along. Okay. Regardless of strategy, the process of traditional science can, in very simple terms, be illustrated as a cycle of observation, and conceptualization, or of justifying and theorizing, to use March and Smith's language from earlier. The main difference between the different research strategies is where in the cycle you start in each investigation: conceptualization and data, or data and conceptualization. Conceptualization and data is also called a data-driven model, or sometimes cognitive bias, as we said before. If you have a belief, then you tend to ignore the facts or data in favor of your belief if the facts or data contradict your belief. So you have to be careful. This is a crude simplification that is destined to provoke scientists from various disciplines and traditions, but it may be helpful to further illustrate the difference between the process of traditional science and the process of design science. I'm reading through this just because we want to get to where the author goes and then decide for ourselves if we believe in everything he says or not. If the process of traditional science can be viewed as a cycle of observation and conceptualization, or theorizing and justifying theories, then the process of design science can be viewed as a cycle of building and evaluating artifacts. Artifacts here is a very generic term, as we defined before. However, to really grasp the process of design science, we need to look more closely into what it entails and think about what it is that makes it scientific. Just because you designed something, is it scientific? And you designed something and it functions, but is it scientific? Let's start with the latter. Regardless of the differences with traditional science presented above, for a design process to be scientific in any sense demands being systematic and transparent. So reproducibility is one of the big criteria. In other words, if our activities are random and not possible for others to follow or reproduce, the process cannot be considered scientific. This links to the principles of reliability and validity, which are commonly used to address scientific rigor, which I address in the next section of this chapter. So evaluation and monitoring and evaluation is what we called before. Nevertheless, to maintain scientific rigor in designing artifacts requires a systematic and transparent design process in which prescriptive assumptions regarding purpose and design criteria are explicitly started, and the choices directed by those assumptions are justified through logical reasoning. The design process used in this book is illustrated in figure 8.3. So the scientific process of designing artifacts, you can start anywhere. You are here on the building step and evaluate step, and you can see how they are all closely linked two ways. And so let's say here we want to define a purpose for an artifact. So we need designing criteria for that artifact. So then you want to think about function and then form. So develop the artifact, so you have now a form, and then you utilize the artifact to see if the form functions to meet the purpose, and then you evaluate the artifact, and then you go back to designing, utilizing, and it's a two-way street. And design criteria for artifact has to have a two-way street with the evaluation of artifact, and the purpose for the artifact also has to be involved in evaluating, because if it doesn't meet the artifact, then you have to go back into this loop as well, right? Makes sense. So the first step in this design process is to clearly define the purpose or purposes of the artifact that is to be designed. This purpose is generally described in rather abstract terms and acts like an overall guiding principle for the rest of the design process. The second step is to define the design criteria that artifacts must meet. These design criteria are prescriptive assumptions about the required function or functions of the artifact, which must be appropriately justified through logical reasoning, informed by established theory or new empirical research. It's here that the crucial link between the descriptive and the prescriptive occurs. So you cross the boundary back and forth, not as an unreflective deduction over the philosophical chasms of Hume's guillotine from chapter 5, but as conscious, transparent arguments grounded in normative values and informed by descriptive research. So you are transitioning between facts and values as purpose and function, and then evaluating and making sure that you are not being chopped off by the Hume's guillotine in terms of not being able to understand the normative values and function together in this basis in this framework. Okay, so I will come back and read the third step next, because I have to now run to a meeting, but maybe let me just finish it. How many more steps are there? Oh, there are more steps, so maybe I shouldn't rush this. So we've looked at first and second step, so we'll come back and look at the remaining steps in the next podcast. Okay, chopping it off kind of in the middle, but that's because again I'm doing this part-time in the middle of other actual duties I have to perform, or I'm obligated to perform. Okay, see you in the next podcast.